Hi guys, today I'm going to show you how to create your first Jmeter test plan, then run it using G script using our local vagrant box. So hopefully you have your vagrant box already configured as I described as I showed you in the previous video. So yeah, let's get started. But before we started, we have to prepare our projects folder. So just go to the your G folder, projects folder. Let me just delete this test plan because I'm going to create it again. So first test plan, it's an empty folder. What we have to do now is just to create a results folder, and that's it. So to create our test plan, I'm going to use the example template that I provided you with. So there are two in the G resources folder. Just for our first test plan, I'm going to use the one with no data file. So let's just copy this file, go to the projects, first test plan, paste it. Now we have to rename this file to the same name as the folder name. So first test plan, and just drag it to Jmeter. Right, so now I'll explain quickly what's already here. So we have a config element, we have the thread group, ultimate thread group, one HTTP sampler, throughput timer, and a bunch of listeners, report listeners. So I'll start from the last one actually. This generate summary results listener will just print the basic statistics to the Jmeter log file, which is used by the G script to actually show you the progress of the current test run. So it's really important to have it, unless you don't want to see the intermediate results while running tests. Right, then we have two listeners that will save only errors. So please notice this this checkbox checked here, and that just will save errors into this file, and in this case into the one with CSV suffix. So why I'm saving the same thing twice? I've noticed that it's really helpful to use CSV file to quickly figure out what went wrong during the test run, and then if you really need it, you can refer to the XML file and just check, just get more details on what went wrong, like what assertions failed, etc., etc. So it's pretty important to configure them just like here. So you have to mark it as, save it as XML, and save all these fields that are pretty useful when debugging your test plan or in the future. Right, in terms of configuring this listener, it's slightly different. Of course, you have to save it as CSV file and mark all these checkbox just like here. Right, actually we can get rid of this plugin with this listener because we're not using Jenkins plugin, so let's just delete it. Right, then we have the generate result listener called generate the results for all the command reporters, and this is pretty important file. Remember to name it as here in the results, save it in the result.gata file, and configure it like this. This is the minimal subset of columns that are required to generate all the graphs using the command line tool. Yeah, basically this tool is just used for this, just to save all the results in one file and then generate graphs from it. Then we have the performance metrics monitor, collector, whatever. This listener will connect to the Perfmon server agent that monitors the performance of the machine that it is running on. In our case, it will be monitoring the vagrant box performance, so it will monitor the CPU, memory swap, and network I/O usage. So that's why you can see the local host here. And actually, it doesn't matter whether you run this test on EC2, on your on Vagrant box, or any Linux host that you have in your network. It will always try to connect to the local host. By the way, the G script automatically starts the server agent for you, so you don't have to do anything else. Just configure this listener to connect to it, and that's it, and collect the data. You can add another one that will monitor the results from the remote host, for example the server that you're running test against, but you need to have a server agent up and running on this host, and then you would have to change the host name, port probably, to connect to it, and save it in a different file. I recommend calling it perf1-remote.jtl. If you monitor the local host, just name it just like here. Finally, we have this auto stop listener. This is pretty cool plugin that will automatically stop the test run if one of the thresholds is breached. So for example, if the response time is greater than latency, or error rate is greater than for any given time interval. Here I'm not using implicit values, I'm just using variables which are pre-configured in these user-defined variables config elements, and as you can see, they are all defined here. And why they are here? Because later on I'll show you how to run the same test with a custom config file, and this custom config file will override all these values that are here. So let's say treat these values as the default ones, and the one that you have in the config file will just override them to meet all your needs. So for example, you can run this test against different environments. Right, so we have a bunch of other variables that are used here to configure the ultimate thread group. So they configure the startup time, delay, startup time, duration, etc. The funny thing is that I've configured the startup time to the same desired number of requests per second, because it's pretty good to ramp up the load quite, maybe not slowly, but you shouldn't be really abrupt. So I prefer to set it to the same number of requests per second, so we can avoid all the problems with generating too many threads at the same time. And finally, we have the this small equation that defines that I came up with my friend after struggling with configuring Jmeter to generate desired number of requests per second instead of generating as many requests as it can. So we come up with this equation that basically used JXL script to calculate the number of threads required to generate the request per second. So what we have here, we have the number of requests divided by number of load generators. Usually you know how many load generators you're going to use to run your tests, so you can provide it in the config file or the custom config file, and then after dividing these two numbers, we multiply it by, in this case is by 4, and 4, why 4? Because here we have the constant throughput timer, and we configure it now to 15, which means that the this thread group will generate maximally 15 requests per second for each thread. So this will simulate a user behavior clicking every 4 seconds, and this is pretty important when you have a service that its response times sometimes get more than, let's say, few hundred milliseconds, or if it gets to, let's say, 3 or 4 seconds. Then sometimes you might end up having some strange behavior in Jmeter. So we've noticed that it's pretty good to configure it to this value. It works with most of the APIs or web services. So you can just tweak it in the docs folder. Sorry, there is this simple Excel spreadsheet that shows you how many threads will be generated depending how many requests per second you want to generate, and how many load generators are you going to use, and how many requests per minute you want to have, how you simulate. So this will show you how many threads are going to be created for on each of the load generators. So if you know that your generator can handle only, let's say, 400 requests, it means that you won't be, no more than 400 threads, then you will be able to generate, let's say, 200 requests per second using this equation. Right, so of course you can tweak it to meet all your needs, but we found this setting quite generic, so hopefully you will find it useful. Right, so I think I have explained everything about this thing. You can read more about this here. Right, now then finally we have the HTTP sampler, so it's also parameterized. So we define the hostname, port, timeouts, using the config file. So there's nothing here to tell more. But I'd like, probably as you, I'd like to test something. Let's say a real website. So I just picked the weather.com as our target. So let's search for any city, for example, Paris, wherever. So let's take the context from here, just copy it and paste it here. So we will just fetch this endpoint from this server. And now let's just copy the host name, and you can paste it here or just go to the local config and replace the test with weather.com, but remember to remove the trailing slash and HTTP here denominator. Then just change the port to 80. And now define the number of requests per second. We're going just to generate 1 request per second using just one load generator, which is our local vagrant box, and then define the duration to whatever, like maybe 60 seconds. Shutter time, we can leave it as here, just 1 second, and delay, protocol, and all the other values, just like here. We don't have to change anything. So okay, we have our test plan saved. If you want, we can just run it just to see whether it works, but before you run it, just disable the local performance metrics collector, because you won't be able to connect and you will end up having seeing a lot of errors. So just let's run it, and here we should see our first results. And nicely, response time dropped to something below 40 milliseconds, which is pretty awesome for this kind of a service. No errors so far, so let's stop it. It means that the test is running correctly. Okay, we can just save it. And if we go to our test plan, you will see all the results files already configured. So let's just get rid of them, and let's go back to our console. And here we have the command that you're going to use to run this test using the local vagrant instance. So as you can see, we run it in the debug mode. We point at the first test plan project. We specify the vagrant configuration and just Jmeter-ec2 script. So what you have to do now, just hit enter. So now the G script is connecting to local vagrant box and installing everything. So actually we can just SSH to it just to see what's going on here. Alright, I have htop installed here, and we can sort it by CPU. So you see that now it's installing everything. It just started the Jmeter server agent, Jmeter. Okay, we also have command runner here and actual Jmeter running here. Right, so that's not important here, so everything looks fine for now. Let's go back to our test, and now we're waiting for the updates. And these updates, as I mentioned before, are possible only thanks to this generate summary result listener. So yes, you can see the generate summary results here, and we have the intermediate results visible. So it's pretty useful to see what's going on if you have time, of course. Okay, so let's wait a few more seconds to for it to finish, and it should finish in just 10-15 seconds. Okay, just finished. So now it's downloading all the results, merging them, and calculating all the basic statistics, and now it's generating graphs and the HTML report. So you can see all the paths here where files are saved, etc. And ta-da! Everything was successful. We couldn't just remove .errors files because there was no such file, so that's fine. And now we can go to the project's results folder, and we can see all the result files. So we have the zipped results, as I described in earlier videos. We have the complete result files, which were combined from all the test runners. In our case, we just used one, so we have just this file is exactly the same one as the one you can find here as this result file. We have the error files for every log generator that we use for our test, but we have just one here, so that's it. We have the Jmeter output file, installed file that shows you what was installed on the remote machine, etc. So just if you want to, you can just dig these files and find something useful for yourself. Then we have a bunch of CSV files. These files just have contain some basic statistics like latency, average value, standard deviation, median, min, max values, etc. For the same statistics are calculated for the response time and response size. So yes, maybe you will find it useful. Right, then we have the response time percentiles and response time percentiles in a different form. So this is the, let's say, raw file generated from the result file, and there is one Python script that actually transposes this file into such format, and this format is understood by the Jenkins plot plugin. So you'll be, if you point at this file and you configure the plot plugin correctly, you will have a nice performance trend showing you the performance response time percentiles over time. So I'll show you this in one of the future videos. Then we have the aggregate file that just contains some basic stats. Just notice the name of this column, this row. This sampler is called get. It is exactly the same name as this one here. So if you have more of them, you will see more lines here. We have the error rate, the actual rate, which is our number of requests per second, which is what we wanted, just one request per second in our case, and a bunch of other statistics that you can also use. You can use to visualize using the plot plugin. Right. So I've described all the CSV files, and finally we have the HTML report with all the nice graphs showing you everything that you possibly would like to see. We have the number of hits per second. Let's go back to it. Actually, it shows 2. Okay, I have to figure it out. I have to check why it's 2. Actually, it should be just 1. Maybe after merging files, something happened. Okay, and then let's go to the number of threads. It's 4, which is exactly what we expected from Jmeter. And then we can't see let's see, performance local. Why? I've disabled this. Listener. So let me just re-enable it. And actually, let's run this test again because it's pretty cool thing. So let me just run it, pause it for you. I'll get back to you in a second. Okay, so script is almost finished. Should finish in a second. Okay, done. So let's go to the results files. We have the new report. Let's open it and let's slide to the last two graphs. You won't see anything from the remote performance metrics collector because we didn't connect to it, but we can see the graph for our local vagrant box, and we have all the performance stats. So we have the CPU usage, memory usage, network I/O, and the swap file usage. So as you can see, we have the multiplier here. So our CPU usage didn't go much further than 50%. Then the memory usage was around 450 megs flat, so we could definitely generate much more traffic than this. Yeah, and all the other graphs were explained in the previous videos, so I hope you will find them. You will find the explanation useful, and I think that's it. Yeah,